Hey everyone, it's Bradley Bush with another algebra video for you. Today we're talking about systems of linear equations in two variables. Because we're using two variables, that means we're in two-dimensional space, so we have an xy coordinate system there, just for a reminder. Our to-do list today, first we have a review of systems of linear equations in two variables, just to kind of get you up to speed. Second, our case study today, which is the purpose of the video, is the infinite solutions scenario. So when you're solving these systems, you have three options for solutions. You have no solution, infinite solutions, or one solution. And this video discusses the infinite solution scenario. I also have a list of video elements in the video details with a timestamp. So if you'd like to skip ahead to a specific part, you're more than welcome to. Let's start. So what is a system of linear equations in two variables? It sounds kind of complicated, but it actually isn't. So let's break it down. So the two variables part, that just means we have an x and a y. You have two variables in your equations. You have equations in this system, and those equations have two variables. That's it. These equations are linear. That just means that both of our variables, the x and the y, have an exponent of 1, and we know that when we have an exponent of 1, it's implied and it's not written, so you'll just see an x and a y that look like they don't have exponents. This means that we're dealing with a line. So we'll have lines in our system, generally two lines, and that's it. Speaking of systems, what is a system? System just means you have more than one line. So we will have two lines, and that's it. That's really all our system is. So that wasn't really as bad as it sounded, right? Let's look at an example system. Here's a system, equation 1, equation 2. My equations have identifiers. I have a number and then a circle around it. So this 1 is an equation label. You can see that we have two variables. They both have 1 as their exponent. So that's an example system. What is a solution? What's an example solution look like? Well, a solution is any point, which is an xy coordinate, that is on both of these lines at the same time. Mathematically, we say that it satisfies both equations simultaneously. So if you plug that xy coordinate back into the two equations, you'd get a true statement like 2 equals 2 or 6 equals 6. So that's really it. All we're doing is we're given two lines, and we look to see where they cross. Because any point where they touch or they cross, you have a point that is shared on both lines. So three possible solutions. We only can have three possible solutions. We never will have anything besides these three options. We have the one solution option, which means they cross at one point and that's it. You might be wondering, how can they not cross twice? Well, by definition, lines are straight, so they're not going to curve back around like I've just drawn here. So if they're straight, they only cross once. So they cross once, that's an option, or there's no solution because the two lines are parallel and never touch, or we have infinite solutions because both lines lie on top of each other, and any point on one line is a point on the other line. So those are your three options. How do you know which of these scenarios you're given? Well, you just start solving the system. That's it. So start solving the system. If you get an answer, you're in option number 1, meaning there's only one solution, as long as you've done your algebra correctly. Otherwise, as you're solving the system, your variables will all drop out, and you'll be left with numbers and an equal sign. If those numbers and equal sign make a true statement, meaning 0 equals 0 or 2 equals 2, those are valid mathematical statements, you're in option number 3, where you have infinite solutions. If those numbers and the equal sign make a false statement, like 0 equals 2, you know you're in option number 2, which means you have no solution because the two lines are parallel. How do you solve these systems? Well, the two biggest and best options we have are the substitution and the addition method. In this video, we will use the substitution method. All right, let's talk about our example here. Infinite solution scenario. Here's our system. We have an equation 1 and equation 2. If we're looking at these equations, we want to get rid of a variable, right? We can see that it's kind of convenient for us because, look, equation 1 is already solved for x. So why don't we just take that x that's already solved and plug it into the x in number 2. So we're going to take equation 1 and we're going to plug it into 2. So if we look down here, we have equation 2 already written. And you notice that there is an x here, 5x minus 20y equals negative 40. That's just equation 2. But instead of having an x, we're going to write what x represents in equation 1. So x represents in equation 1 4y minus 8. So let's write that down right here. 4y minus 8. And now we just have to do some algebra. So we'll need to multiply that 5 in to the 4y and to the 8, and let's see what we get. So 5 times 4y gives us 20y. 5 times negative 8 is negative 40. And then we have negative 20y equals negative 40. And look at that. We have some stuff that cancels, right? The 20y, the negative 20 cancels. And what does that leave us with? That leaves us with negative 40 equals negative 40. So you're thinking all of my variables dropped out. They did. And what's left? Numbers and an equal sign. And they make a true statement. Negative 40 does equal negative 40. So the variables dropped out and we were left with a true statement. So that means we have infinite solutions. So if we look over at the graph, you can see equation 1 and equation 2 here, and they're both the same line. So any point on one is a point on the other. So we have infinite solutions. So how would you write the solution set for this type of a problem? Well, we can use something called set builder notation to use shorthand to describe all of these solutions, because there's an infinite number, so we can't list them all, obviously. And this is how we would do it. We would say, and I've got there are two options. You could use either of these two options, the top or the bottom. Those are both valid solution descriptions. So we're going to say that this is a set. So these curly brackets here, that just denotes that we are using set builder notation, and that everything inside is a set, meaning it's a group of all the solutions. The x and the y at the beginning, this x and y, this is read any x and y. So this here is any x and y such that, this little vertical line right here means such that, any x and y such that make this equation true. So any x and y that make this equation true, that's the solution. So that's why we can have two solutions, right? Because we could put in equation 1 or we could put in equation 2. And that's what we have for the two options. So really this is just saying any x and y at the beginning, that makes this equation true. That's a solution for us. So that's it. That's how you would describe the solution, and this is how you would solve a system of linear equations in two variables with infinite solutions using the substitution method. Hopefully this helps. If it did, please subscribe to the channel, and thanks for watching. Have a great day.